Hi there, welcome to the USurfaceMesh plugin demonstration video. For this one I wanted to go over the optimization of the meshes, because when it comes to the mesh building process, there's quite a lot of to get a really high detail you actually need to include quite a lot of quads in the mesh, which means you need quite high complexity. Or a low complexity, but then increase the grid sizes. So first of all, let's start out by creating a mesh on the landscape. So first thing we're going to do is sculpt onto the landscape. So let's go into landscape mode. We'll go to sculpt and we need to flatten the mesh. So first of all, let's pick the height of the landscape, and then we'll raise it up by 10 meters, so we'll go to 1100. We'll increase the brush size, it's a little bit too much. We'll paint it onto the right here, create some little area. Right, so once we've got our surface, then we're going to go over to search classes and we're going to type in USurf. We'll drag in the USurfaceMesh grid. That'll create our preview mesh. And then we'll choose setup to build. What that will do is it'll actually turn on the creation of the mesh, and then it'll project down the blue arrow onto the landscape below. So by default the complexity, if we switch into wireframe mode, the complexity is 1, and the horizontal dimension and vertical dimension is 100, so that's 100 centimeters. So that means that each quad is 1 meter by 1 meter with a complexity of 1. If we increase that to 2, then now it subdivides each quad and then makes 4 quads. And so on and so on. As you increase the complexity, then the mesh gets denser. So at the moment we have 800 polygons. And if we increase that to 10, then we now end up with 20,000 polygons. And as you can see, it's subdivided it even more. And if we go and change that back down to 5, which will then decrease the complexity, and now if we want to add some height to it, we'll go to settings and height, and we'll go use height texture. That will enable the height texture settings here in this panel, and then inside the USurfaceMesh content folder we'll go to height maps. And we'll just choose one of the height maps that's already loaded here. It doesn't really matter which one. I suppose we could choose the creature for now. It might be a little bit fun. So then we set the max height. So at the moment the grid is projected down onto the landscape and it has a min height of 0. So that means it will sit directly on the surface of whatever it's projected onto. And then that basically, the min height, is the black area in the texture. So if you then have the max height at 100 units, which is 1 meter, then anything that is pure white in the texture will be at 100 centimeters above that surface of whatever it's projected onto. So if we change that to 200, then now it'll be just at the sort of center of this texture. It'll be 2 meters above the landscape. And of course at the moment you can't really see very much detail in the texture because the mesh that's been projected, it doesn't have enough density of quads because the complexity is too low. So what we need to do is go to that complexity section and then increase this to a bigger number, and then once it's processed you see that the mesh becomes a lot denser, and at the moment that's got 80,000 polygons. So to get rid of some polygons, what we can do is we can go back to that height section. So what we can do is go to Shift Before, which will, when Remove Polygons is enabled, that means we'll shift before removal. And then Shift After is the shift after polygons have been removed. So Shift Before, that'll make them, if we go minus, it'll make them go underneath the landscape. So we'll go down by 6 units, or 6 centimeters. And if we switch back to material mode, then now that has forced all of them polygons underneath the landscape. So if we now turn on Remove Polygons, then all of them polygons will now be removed that are underneath, they're fully underneath the landscape. Any ones that are where they're the 3 vertices that make up the polygon, if any one of them is above the landscape, then that won't be removed. Only if all 3 vertices are underneath the landscape will that polygon actually be removed. So now that we've got that underneath there, we now have a choice, because when we're looking at how dense the mesh is, we have to decide whether we want a higher complexity, which is then going to give more detail, but it's only going to give more detail if the texture that you're using has enough detail in it at the resolution that it's at. So basically it means that you just look at the mesh and then see what the density actually is. In some cases you may want to have a lower density because it's a higher density would be wasted on the mesh. It doesn't really need that higher density. So as you can see where the curved areas are on the texture, you're going to get breakup in the polygons because there isn't enough polygons there to actually show the curve at its a high enough resolution. So if we increase the complexity, then now there'll be more polygons to show that the detail of those curves. And obviously if we increase that again, as you increase the complexity, then you're going to make the mesh denser with more polygons, so therefore it's going to take a lot longer to process all of that data. So here we have a lot more detail now. This is 123,566 polygons, and that's with polygons removed. So imagine how many there would be if those polygons weren't removed. So once you've got the mesh that you actually want, then you can stamp the mesh. So we'll quickly go to where we want to stamp it, and then we'll choose. Now when it comes to optimization of your mesh, you need to choose a LODE group. You don't have to choose a LODE group, you can choose none and then go in and optimize it yourself, but by default you can load in any one of these LODE groups that are built into Unreal Engine. So if you choose any one of them and then choose stamp, now that static mesh will be made and the static mesh actor will be placed into the world with that static mesh inside of it. So the plugin will then be disabled, and from there on it's just a regular static mesh. Okay, so now that we've got the mesh built, we'll switch back to material mode again. So this is now a static mesh, and it's a static mesh actor in the world that's got a static mesh loaded into it. So what we need to do now is we need to go and load up the static mesh. So if we double click on that, and then we look around the model in here, so we can see the detail that it has, and as you can see the mesh shows as it's projected on the landscape. And if we view it in wireframe mode, then we can see it's a very high density mesh, and at the top left hand side you've got the triangle number, so that's our polygon number. And on the right hand side, if you go to the LODE section, then under LODE 0 we've got our reduction settings. So by default the first LODE is going to be 100% of the triangles, so that's all of them polygons that we created with the tool. And by choosing a LODE group of Deco in this case, then the LODE picker here shows that there are 4 LODs. So we've got our LODE 0 at the highest number of polygons, and then each one is being told to reduce by a certain amount. So this is looks like it's half, and then go to LODE 2, so that's now half again, and LODE 3 would be half again. So there's several things that we can do now. The first one we can do is we can actually reduce the number of polygons to start with, so that would be LODE 0. So if we change back to LODE Auto, and then we go to percentage triangles, and we change that to be, well, if we think about how many polygons we actually want for a model of this size and detail, so we could say that, you know, we're willing to have 40,000 polygons here, maybe 30,000 polygons. So therefore, you know, if we went for something like 30%, and then we choose apply changes, and we let that calculate, so that's reduced it to 37,000 polygons. And by looking at the mesh, you can see whether there is any detail change at all. If it looks the same, then there's no need to increase that percentage of triangles, because the number of polygons that are there is sufficient to show all of the detail of the mesh. So if we switch over to wireframe mode, then we can now see that where the mesh curves over, it's requiring higher details there, so therefore it's left them polygons in place, whereas in flatter areas where the detail is not required to show any geometry change, then it's optimized that area and decreased the number of polygons. So from there on, because we still have the LODE group in place with Deco, is we can actually move away from the mesh, and it will LODE down at some point. There you go, it LODE down to LODE 1, and if we go further away, LODE 2. But if you want to change the LODE settings, LODE distances, then you can manually go into each LODE, and you can say, well, at LODE 1, at the moment it's got a screen size of 0.5, so if we want it to LODE down to this level at an earlier distance, a closer distance, then we need to change the screen size at which that happens. So to do that, we need to come down to, see if I can find it, it's auto compute LODE distances, and we need to turn that off. So now we now get the capability to edit the screen size at which this LODE is applied. So if we increase that to say 0.8, and we switch back to LODE Auto, then now when we zoom away, it should LODE down to that LODE 1 a lot sooner. And there you go, it does it at that distance. If you want to know what distance to apply into the screen size, then just set the zoom to the level that you want it to do it, and then on the top left hand side it says current screen size 0.9. So if we choose LODE 1 again and we change that screen size to 0.9, and then we switch back to LODE Auto again, then now we get that higher LODE 0 with the 30% reduction that we set. And then as we go down to zoom out to 0.9, then now the Deco LODE group is applied, which then the Deco one seems to be applying a 50% each time over 4 LODE groups, so therefore it now halves the 37,000 down to 18,500 polygons. So again, if we switch back to, well, actually we'll keep it on LODE Auto and we'll go to the distance that we want to set LODE to, so about there. We'll note the number, maybe 0.6, so we'll go to LODE 2, and then we'll now set the screen size to be 0.6. Switch back to LODE Auto again. Now zoom out again and say, well, at this distance we want the final LODE to be displayed, and the screen size here is 0.4. So we go to LODE 3, and now we can set the screen size to be 0.4, and now we switch back to LODE Auto. So what we've got now is LODE 0 out to that distance, and then it switches to LODE 2 just there, and then it switches to LODE 3 there. So by this distance you're seeing the lowest LODE level, which has 4,500 polygons in it. And obviously you can keep going and add more as you see fit. So a couple of other things that we can do to the mesh. So by default, with the USurfaceMesh, is to be able to project onto meshes that are produced by the plugin, we need to turn on double-sided geometry. And what this does is when something is projected onto the mesh that has already been stamped previously, if you use the shift before to try and get the mesh to be underneath that mesh, then to be able to cast the rays up to meet that mesh that was already stamped, it needs to be responding to the geometry, the collision. So therefore, to do that, each mesh, when it is stamped, enables double-sided geometry, which allows that facility of removing the polygons. It doesn't affect the projection, only the removal, because the normals that are being displayed towards the projecting surface are responding to that collision channel. It's only for back-facing polygons that would need that double-sided geometry. So if we go into here and we try and find, I can never find where double-sided geometry, here we go. So it's in the collision section and it's double-sided geometry, and at the moment that is turned on. So if you're wanting to optimize your meshes, then you can go into each static mesh and disable double-sided geometry. Inside the world, if that mesh exists, then that means that if you try and project onto this and then shift down through it, then try and remove polygons, then this mesh won't be responding to that collision, and so therefore polygons won't be removed. So just bear that in mind, that if some of your meshes become unresponsive to the removal of polygons, then it's probably because those meshes do not have this setting turned on. And I suppose another one to bear in mind is the collision complexity as well, which is by default it enables complex collision as simple. That means that it actually uses the per polygon collision to detect its collisions against the mesh. So you can always go through your static meshes inside the content browser and actually select those static meshes, and then go to asset actions and then bulk edit via property matrix, and then collectively together disable double-sided geometry. So if we go to some of the meshes that I've stamped before and we select those, we can go to Asset Actions and then Bulk Edit via Property Matrix, and with those in here we can go to Collision, see if I can find it in here. Right, so inside of here is actually under Static Mesh, Body Setup, and then Double-Sided Geometry, and then we can turn that off and then choose to save all of these meshes. So as we're building many meshes, it's probably better to leave double-sided geometry on for now, so that the mesh can respond correctly to remove any polygons. So another thing you can do as well is you can always go in and manually edit the LODs. So we can switch the LOD group to none, and then what we can choose is the number of LODs manually. So if we want 6 LODs, then we can choose Apply Changes. We'll just let that compute. So inside of the LOD picker, we'll now have our 6 LODs, and if we go to the 4th LOD, which was the last one before we increase the number to 6, at the moment we've got a screen size of 0.4 with a reduction value of 12.5. So if we go to LOD 4, which is actually the 5th LOD, is we can change the screen size to be something lower, so maybe 0.25, and try and remember what that number was. So it was 12.5, so we can change that to maybe 8 and apply those changes. So 0.25 and 8, so now we'll change back to the last LOD, and we'll go to 0.2 with maybe 6. So now if we switch back to LOD Auto and we zoom out, then we can see it switching down. So that is LOD 4, and then we've got our LOD 5. So that's the final LOD, which is only 2,200 polygons. Whereas if we zoom all the way in again, then we go to our highest LOD. So that's a little bit of optimization for some of the meshes. If you've liked this video, then please subscribe, and I'll see you in the next one. Thanks for joining me.